Point one, our goal is going to be solve equations. So, solve equations. That's our goal. Now, what does it mean that to solve an equation or to find the solution? Well, let me give you kind of a nice informal definition. A solution to an equation is a number that satisfies the equation. Is a number that satisfies, and by that I mean makes the equation true. So a number that satisfies the equation. So what can you plug into the equation to make it work? Well, let's test a few things just to kind of get familiar with this idea of a solution to an equation. So problem number 18, for instance, gives you this equation: x minus 50 equals 60. And the question is 110 the solution? Now, on an exam, if I gave you a problem like this, I'm going to ask for just a little bit more than a yes or no. I want to see a reason why. I want you to show me that you understand what's going on. So what I'd be looking for is for you to put in that number and check it. 110 minus 50 equals 60. True or false? True. So the answer, yes, 110 is a solution. Now, if you want to use a complete sentence there, that's great. If you want to just write yes, that's great too. But I do want to see something like that to check it. Yes? Oh, that's going to be solving it. Yeah, and we're going to do that too. Their only goal here was to ask, is this a solution? All right, so for instance, you could have problems like number 28 that, maybe aren't quite as clear. But there was another question on this one as well, though. So what you're doing is solving it, though. All right? And then solving it is one way to determine it, but it might be a little bit harder to do that in some circumstances. For instance, and since you're asking, if I gave you x squared minus x minus 12 equals 0, is 4 a solution? I mean, so moving the 12 around is really not the way to solve this one. And with what you guys might know at this point, some of you might be able to solve it, some of you might not. But no, you don't. You wouldn't want to do it that way. Trust me. If I give you a problem like this, what I would expect would be 4 squared minus 4 minus 12. Test it that way. So 16 minus 4 minus 12, okay, that's 12 minus 12, and yeah, that does equal 0. All right, so that's what I expect when I ask you to check a solution. Trust me, I can write some problems that are really, really hard, and you don't want to solve them. If I'm asking you to check if it's a solution, that's all I want. This might be a good example as well. Problem number 28. The question is whether or not r equals negative 45 is a solution. So again, the idea is to substitute in and check it. So 30 minus, and here's where you got to be careful with the parentheses, right? I've been consistent all day here today, suggesting that when you substitute, you do so with parentheses. Here, it's so that you don't miss the double negative here. So, Karanja, how does what's inside the absolute value simplify? Good. That's a plus, so you get the absolute value of 75. Thank you. So, does the absolute value of 75 equal 15? No. So what's that telling me about the solution here, or about this as a solution? Not a solution. So r equals negative 45 is not a solution. If it was a solution, they'd have to equal. Can anyone fix it? Can anyone figure out what would be the solution? Yeah. Yeah, take away the negative. If this was positive 45, then 30 minus 45 would be negative 15. But then when you take the absolute value, you get positive 15. So positive 45 would actually work there. Now, what you said earlier, though, about, well, this is what I would do to get the solution was exactly right. We're going to use a couple different properties in terms of finding solutions to equations. One of them is the additive, or excuse me, the addition property of equality. There's a nice picture of this on page 103. And Sam noted for us that 103 is my favorite number today, right? All right, that's cool. So if you have two things that are equal, and here the equals is represented by this balance scale, if you add the same thing to both sides, if I add 2 here, if I add 2 here, you're still going to be in balance. Your equation is still going to equal. So what this is saying can be translated to numbers. For instance, problem number 42. Negative 23 equals y minus 19. Now this equation, or this is an equation that has a variable, but it's in balance. These things equal each other. So if I add the same thing to both sides of the equation, they'll still equal each other. Here's what I expect you to do. Look at the variable. What's being done to the variable? You're subtracting 19. So let's do the opposite. What's the opposite of subtracting 19? Adding 19. So let's add 19 to both sides. On the right-hand side, we get a y, because the 19 and the negative 19 cancel each other out. What about the left-hand side? What do we get? Thank you. Negative 4. All right, good deal. How could I check that? If I was looking at that going, I'm not sure it looks right. Yes. Thanks, gentlemen. So if I wanted to, I could check it. You can check all your answers to equations in this course. You can know before you hand in the exam that you got this right or didn't by plugging it back in. So negative 4 minus 19 is 23, so it does check. Let's try a couple more here. Problem number 38. X minus 34 equals 19. And problem 48. 9.4 plus h equals 8.1. Our goal in all these things is to solve it by isolating the variable. Look at the variable, figure out, well, what's the opposite? What's going to undo this? What undoes subtracting 34? Add 34. Now on the problem 48, you're adding 9.4. What's the opposite of adding 9.4? Yeah, subtract 9.4, or you can think of it as adding negative 9.4, whichever is convenient for you. Carly today? All right. Ted. Good man. What's the first one, please? 53. Good. Did you get the second one, too? All right. Negative 1.3. Nice. Yeah, please.
I did the 19. I did negative 19. So instead the 34. Can we do that?
Well, if you subtracted 19 from both sides, it's an interesting question.
But they give me negative 53.
Well, but let's keep track of where that would be. If you subtracted 19 from both sides, you get x minus 53 equals 0, right? You haven't really finished solving yet, right? So how would you solve? Well, at that point, I would add 53 to both sides and get x equals 53. But it took a little bit longer to get there, right? So what I would suggest is that when you're looking at these problems, you say, all right, what do I need to do to get the variable by itself? All right. The opposite of subtracting 34 is to add 34. Okay. So what you were doing will get you there. Let's take a look at problem number 50. Y over 7 equals 12. Somebody describe to me what's happening to the variable. It's being divided. So what would be the opposite of... Yeah, good. So we're going to multiply. The opposite of division is multiplication. So we're going to go back to this idea of opposite operations. So I'm going to take and multiply both sides by 7. Does it help you? Does it help if we write this as 7 over 1? Okay, so let's do that. How's that going to simplify then? Yep, thank you. The 7s here cancel. You're just left with a y on the left-hand side and 84 on the right-hand side. Your turn for one like that. N divided by n divided by 9 equals negative 2. Molly? Negative 18. All right, so the opposite of dividing by 9 is to multiply by 9. And I like that you took care of the negative sign correctly. We get n equals negative 18. Nice. Thank you. Okay. Let's continue with problem number 58. And I hope you're starting to see a little bit of a theme here. 5y equals 45. What is being done? Lakendra, let me pick on you for a second. What's the 5 doing to the y? And what's the opposite of multiplication? Divide. What should I divide by? 5. And 5 goes into 45 9 times. Great. Thank you. LaShawn, how could I check my answer if I wanted to? Good. Plug it in 5 times 9. 5 times 9 is 45, so it checks. You can check all your answers for all these equations. Always. That's a cool thing you can do. I don't know of any other class you can do that in. To always be able to check your answers like that. Let me give you a couple to try. Now, I'll give you... Now, we'll do the first one together and see what you can do with the second one. Is it positive 50 here? Thank you. Is the variable all by itself?
No. -1.
Yeah, it's being multiplied by -1. So what's the opposite of being multiplied by -1? Divide by -1. Most people are going to feel comfortable doing this. Divided by -1. And that's going to simplify, right? What does y equal? -50. But let's take a look at this and try something different. Because this one's a little bit unique. And I'll just show you a different way to work on it because you're going to run into this kind of problem quite often. What if instead of multiplying or dividing by -1, I multiplied by -1? Does that work? Does that solve this? What's a negative times a negative? Positive. And a negative times a positive is negative. So it works the same. You're dividing by -1 or multiplying by -1, whatever you find convenient. Why don't you try problem 64? Chelsea? What should we do in this one? Try it. Kasnaya? Okay. All right, so you can think of it as dividing both sides by -1. And what do we get? Yeah, -11/16. Cool. So, I mean, very simply put, you've got a positive divided by a negative, and you're going to get a negative answer. So, that's it. That's all there is to it on 64. Thank you. How about problem number 70? Let me squeeze that in over here. D over 49 equals 0. What do I have to do to solve this one? Good. The opposite of dividing by 49 is to multiply by 49. So D over 49. Now I got to multiply both sides of the equation. And that's an important thing to keep in mind. Is that whatever you do to the left-hand side of the equation, you also have to do to the right-hand side of the equation. So you have to treat both sides the same. And Deja. Where's Deja today? Oh, Deja. Let's see. Dula. What do we get? What's our solution here? Some help there for him, maybe? D equals 0. Good. Something times 0 is always going to be 0, regardless. Okay. Let's do a couple more to kind of finish things up. Problem number 94. Now this stuff is a little bit less challenging than the stuff we're going to get later on. So what you should do is try and really focus hard on mastering this stuff now because the first exam is going to be the easiest. It's not that I get mean later in the course. You know, after the drop bad day, you know, I don't turn into Dr. Jekyll into Mr. Hyde. But the material does get a little bit more challenging, so do good on the first test. Try and lock away an A right away. Negative 14 thirds times C equals 7. There's a couple ways you can do this one. We saw a hint at this in the previous section. One way to think of this is, gee, C is being multiplied by this number. What's the opposite operation of multiplication? Division. All right, that's one way to do it, and it'll work. It's a little bit of the long way. There's just kind of an extra step. So let me suggest something we saw in section 1.9, and that is to multiply by the reciprocal. What's the reciprocal of 14 thirds? 3 over 14. Now, in addition to taking the reciprocal, I also have to have the negative there. So it's negative 3 over 14. That doesn't disappear. Can anyone suggest something that I can put here on the right-hand side to make this a little bit easier? Yeah, let's write it over 1. Now on the left-hand side, you get a lot of really nice simplification, right? In fact, do I need to really think about this? What happens when you multiply a number by its reciprocal? What are you going to get? 1. So I'm just going to get a big 1 there. 1C. In fact, better yet, just a C. On the right-hand side, I should get some simplification. I do get some simplification. Yeah, you can cancel the 7 and 14. 7 goes into 7 once and into 14 twice. What's left on the right-hand side? Negative 3 over 2. For those of you who are like, you know, I'd really be more comfortable dividing, that's fine. If you look at that and say, gee, the opposite operation of multiplication is division, then that's fine. Let me just show you what would happen if we did it with division. So if I'm going to divide, I would divide both sides by negative 14 over 3. Negative 14 over 3. Okay. On the left-hand side, something divided by itself cancels out. So I just get the C. On the right-hand side, I've got 7 divided by a fraction. 7 divided by this. Well, what happens when you divide by a fraction? What do you do to divide by a fraction? Multiply by the reciprocal. And that's what we did anyways, right? So really multiplying by the reciprocal just kind of saved us a step here. That's all it did. You're still going to get the same answer of negative 3/2. It works either way. Why don't you try that for problem number 74? 9/7 times D equals 81. Got it? It could be 14. I'm not sure it is 14. I don't know. You guys tell me. Is it 14? All right. So let's take a look here. If we multiply both sides by the reciprocal, what's the reciprocal that I'm going to use? 7 over 9. 7 over 9. Now on the right-hand side, I'll write that as over 81. Okay? How does the left-hand side simplify? 1. Good. So it's just D. That's all that's left. On the right-hand side, there's a mathematical operation called gazinta, right? 9 gazinta 9, 81, 9 times. So I'm left with 9 times 7, 63. Cool. There you go. All right. Last one, really super quick. 82. 9a equals 0. A is being multiplied by a number, right? So the opposite of that operation would be to divide. What does A equal? 0. How would it be undefined? In what circumstances would you get undefined here? Yeah, if you're dividing by 0, that's when you get undefined. So, quick reminder there. For homework, try 17 through 95 and 105, just the odds.